So here's the problem I'd like to solve for you. It's worksheet 4, number 4. You're on a 50-meter building. 20 meters away is a 75-meter building. You throw a hook to the taller building so it just catches the top edge without going any higher. That's important. So you can swing over. The question is, what velocity must you throw the hook? Let me work this on a different piece of paper here. All right. So it's always good to draw yourself a little picture. So my picture will not be fancy, but there's my 50-meter building, and then next to it is a 75-meter building. 75 meters. The distance between them, 20 meters. Now, the fact that you're throwing a hook from here to here, which is a height differential of 25 meters, we can call this, I'm going to go ahead and call that H. H is 25 meters. You could call it delta Y, whatever you want. The fact that it doesn't go any higher means that when you throw it, the projectile levels out right at that point. Now the condition for not going any higher is that Vy is equal to 0 at that point. Very, very important. Our goal is to, I drew this kind of funny, like I usually do. The initial velocity, the initial velocity which has magnitude and the direction. So that's what we're trying to find. What is the velocity? Now there's different ways to do this, which is true always. Every projectile motion has more than one way to solve it, and all you have to do is figure out one valid way, and then everything's good. Now one approach I could take is say, wait a minute, this is just like being on the ground. Throwing something up to a certain height is the same symmetrically as having it come back down to the same elevation. So we could use H is equal to 1/2 gt squared, which is the reduction of equation 5. And we could get the time from that. That would be really useful. That's one approach, and then do whatever else you need. I'm going to do this, however. I'm going to use equation 6. Vy squared is equal to Vy0 squared minus 2gh. Recognizing that my vertical velocity at the time I'm doing this analysis is 0. Therefore, Vy0, the initial velocity, is equal to square root of 2gh. Why is that important? Because the initial velocity in the vertical, Vy0, along with Vx, will give me everything I need to specify the velocity, the magnitude, and angle. So here's the first part. So Vy0, square root of 2 times 9.8 times 25. Pull out our calculator. Square root of 19.6 times 25 gives us, this should be equal to 22.1 meters per second. Okay, there's Vy0. And now, what are we going to do with that? Well, we do know that Vy is equal to Vy0 minus gt. So now that we know what Vy0 is, we could get the time. Well, you might wonder, why do we need to know that? I mean, there's Vy0. Let's just get Vx. So let's say that we're recognizing that we need Vx. Well, Vx is equal to, see, velocity is distance over time, d over t, all right? And that is, this distance is in the x direction. That's really x over t, or 20 over t. And so we get our Vx, which we also need by knowing the time. So I'm going to use this to solve for the time, which we could have, again, we could have used this equation to solve for time as well. And maybe that would be a preferable way for you. Since this is 0, then t is equal to Vy0 over G, which is 22.1 over 9.8 divided by 9.8 gives us 2.26. 2.26 seconds. Very good. Quantities that we need. So this then is 20 over 2.26. 20 divided by 2.26 is 8.85. 8.85 meters per second. So there's Vx. So V is equal to square root of the sum of the squares, 22.1 squared plus 8.85 squared. Let's plug that in. 22.1 x squared plus 8.85 x squared. Square root thereof is equal to 23.8 meters per second. How about our angle? Theta is equal to the inverse tangent of opposite, recognizing, of course, here that we have Vx, Vy0, like that. There's our vector V, theta. So inverse tangent of opposite over adjacent, Vy0 over Vx. Inverse tangent of Vy0 is 22.1 divided by 8.85, and that gives us 22.1 divided by 8.85 quantity, and that is 68, about 68 degrees. So the answer is V is equal to 23.8 meters per second at 68 degrees plus x, and that is our final answer.